All right, so my name is David Turner, and I'll be your instructor for this course. And there's also an assistant, student teaching assistant, Mark Swope, and you'll meet him in the lab. So you'll be submitting a lot of your assignments to Mark during the course of this course. And as I said before, that everything you need is basically in this website here. All the instructions, the reading materials. I'm recording this lecture right now, and I'll post this so that you can review what we covered today in video format. Actually, these are notes to myself. I'm preparing to make this class a hybrid online course in fall. So that means the lectures will all be online, but the labs will still be on campus. So I'm just kind of getting ready for that now. So here's the syllabus. So you might want to look through this, get familiar with it. So that's for you to read. There's a chart here that describes the readability criteria for source code. So in this class, you'll be writing, and and Mark, the TA in particular, will be evaluating your writing, but you won't be writing in English. You're not going to submit English. You're going to submit code that's written in C++. There's a computer language called C++. So you'll be writing computer programs in the C++ language and submitting notes. Oh, there's Mark right there. Yeah. So there we go. And these are, just like writing in English, it's important that your code is readable to humans, not just to computers, because source code that is used to build programs obviously has to be readable by computers. So that's the source code is what's used to generate an executable program. But a lot of times it's humans that need to read the source code because the source code has to be modified or it has to be corrected because of a bug. And so the source code ends up being read over and over again normally in a normal program. And for that reason, it's important that the source code is clean, well organized, and structured in a way that displays its logic, in a way that displays how the code is working and what is it telling the computer to do. So there are certain things that you can do to help express the functionality of your code and how it's organized. And so so I've developed this table of criteria that we'll use when evaluating your source code. So you might want to take a look at this and try to understand this. I would say the most critical criterion to become familiar with and master in this course is indentation. Your indentation is, how far in from the margin a piece of text appears. And you can have different levels of indentation. Like you can think of an outline that has multiple levels of indentation, or a tree view of a file system where you have files within directories, within other directories, or within folders. Most people call them folders. So indentation expresses logical organization or structure. So that's very important when you're writing source code, that you use indentation to express the logical structure of your code. And there are different approaches to indentation. But you need to have a logical approach. Your approach has to make sense. And in addition to that, you have to apply the approach consistently. You can't mix different approaches in the same source code file. That's too hard to read. So once you decide on one pattern for indentation, which is logical and expressive of the structure of your code, then you want to stick to that pattern. So that's consistency. So that's also very important. And all right, so that's the syllabus. Any questions about the syllabus you want to talk about? Okay. So the way we have it organized here, there's basically, these meetings are 10 lab meetings. So the course is organized around you doing programming or you taking quizzes. So the lecture is here, and I'm giving you the lecture now. So I'll be providing the lecture 2 times a week. And like I said, I'll be recording those lectures and posting those. So in that sense, you don't even have to come. You can be at home and watch the lecture at home if you like. That's a choice that you have. But you need to come to the labs, and there's 10 lab meetings, and there's 2 lab sections. So you'll be enrolled in one of the 2 lab sections. So you just have to know which one that is. Attend that lab. Now, what happens in a lab? In the lab, we go over the material that's in the lecture, possibly if it's needed. But mainly you want to focus on these activities. So these are problem sets, and you need to focus on working through these problem sets. Now you won't be able to complete the problem sets in the lab. So you can start them in the lab, or you can start them before the lab and work on them in the lab, work on them after the lab session is over. So the focus is on these problem sets. And the problem sets are programming problems, except for the first lab. And that's how learning the command line and issuing commands from what's called the command line interface. That's a little bit different from the other labs. So we cover material in the labs. You have time, you sit there and work, to consult with people around you, to consult with Mark and myself, and just through an active approach, try to master this material. And then you'll notice in this activity, there's some introductory stuff, preparation, and then there's some instructions, what to do. And there's the point scores. This is 10 points, for instance. This is 20 points, doing this stuff. You have to read those instructions and carry out those activities. And then when you're done the activity, which may occur in the lab itself or maybe a day or 2 after the lab, then you submit your work. And generally that means sending an email to Mark and CCing me, and provide a link to what's called your workspace. So I'll show you workspaces in just a moment. And so we'll be able to look at your work that you're submitting. And then at the end, you'll see there are example quiz questions. So in the next lab session, we'll start the session with a quiz. So maybe a 15-minute quiz at the beginning of each lab. And it covers the material that's been studied up until that point. It focuses on the previous activity, but it can include everything presented in the class up to that point. So these are some sample quiz questions. And these are questions that I've had in my exams in the past. All right, so these will resemble the final exam. So each lab, except the first lab, has a quiz. And the final exam is in the 10th lab meeting. And the final exam will just look like lots of quizzes merged together to make one long, exam paper. So that's the format of the course. There's 8 quizzes and 1 final exam. Those are graded. And then there are the submissions of the assignments. That's another component that contributes to your grade. And to keep track of how you're doing in the class, we're going to give you an ID. So your ID will be one of these IDs here. And then you'll be able to see what we think you have submitted so far to this point. This is problem 1 of activity 1, or assignment 1. This is problem 2 of assignment 1. This is quiz 1, which covers the material in the first activity, but you take it in the second lab or second activity period. So these are all of the graded components in the course. These are the score values here. That's the total score value there, 1,090. So you'll be able to keep track of your progress using that grade sheet. Any questions so far? All right, let's take a look at this first activity. And when I do that, well, before I do that, I'm going to go over here. This is the overview. I'm going to talk about what computers are, file systems, operating system languages, compilers, console programs. Here's an example of a program. Here's the same program reformatted. So you need to read that. This is stuff for you to read. And then we have additional reading here as well. And this is a document here that Mark has provided. This is a Gateway to Computer Science. This is pretty good. It's 2 pages long, or maybe 3 pages rather, 2.5. This gives a very good overview of this course. So this will get you, read through this document, it'll help get you oriented, help you start, because what you need to do in this class is start to form a mental model about how the computer works. Like now you have a mental model about how your computer works. You know, maybe you have a laptop and it's running Windows or it's running OS 10 and you're interacting with those devices. And you have an idea, you have a mental model that you use to interact with these devices. And now what we need to do in this course is sort of refine that model or develop that model, extend it, so that you get to a deeper understanding or more detailed model of how the computer works. How do you program it? How do programs, how are they specified? How are they run? How do you interact with the operating system from the command line interface, which is something that we're going to cover. So this document will help sort of get you oriented to start thinking in new terms about the computer or your computer that you're going to be working on. All right, so that's the reading material. You should study these before the activities. Here they are all in here. This is for you to do on your own before the activity starts. I'm going to jump into this activity here. So there's some background business here. Then there's a preparation section. Now here, what you need to do is create an account with the Cloudnine system. I'm going to just maximize that. So you can, this is a free resource. I mean, you can pay for this as well. They're giving it to us for free because they want us to become paying customers. And this is a software development environment which is geared towards web development. It's not geared towards developing applications that you install and run on a desktop computer. It's geared towards developing programs that you install and run on a remote server machine that devices like cell phones and tablets communicate with over the internet, or desktop machines as well, in particular browsers. So a browser running on a desktop machine is going to be contacting servers over the internet. So this development environment is geared towards developing programs that run on the server side of that equation. So it's not, I wouldn't say it's exactly it's not a perfect fit for this class. On the other hand, it provides enough functionality to satisfy our needs, plus it's extremely convenient. So I think it's a good choice to go with this. It's called Cloudnine. And so what you do here is you can create a workspace. So you'll be creating a workspace, and I'm going to show you what you'll do. After you create a free account, you need to create a workspace called CSC 201. It's all in the instructions here. Create a workspace named CSC 201. It says using the C++ project type. You know what? I don't want that. I've got to take that out. That was a mistake. I don't know how that got in there. I want to do using the blank project type. So is that what I called it? Yeah, blank right there. Now that's what I wanted to do. Now, the reason I'm not picking the C++ template is because it's the same underlying configuration. It's just that the C++ template throws in some files to help you get started on projects. But we're not going to look at those files. It throws in a make file. But we're not going to learn about make files in this course. In the next course, you'll probably learn about make files, but not in this course. Unless you want to. We're here to help, right, Mark? Yeah, okay. So, but that's just an extra layer of work that, we have enough to do without learning everything. So that's one thing I wanted to cut out. So there's a blank workspace. Creating containers. So you can think of this as a remote virtual machine, and you have control of this remote virtual machine, and you're what's called the root user or the administrator. And this remote virtual machine is running the Linux operating system. And in particular, it's running the Ubuntu distribution of the Linux operating system. But only the console-based applications are used, because we're not going to interact with this remote virtual machine instance using a graphical user interface. I mean, other than what we see here in the browser. We're going to be accessing this remote virtual machine using the command line, which is shown down here. Let's see if I can make this a little easier to read. Let's see. There must be settings in here somewhere. No. There must be a place to change the font size. Anybody logged into this? Their preferences. And let's see, we've got user settings, user interface. Just jump right in there if you see what I need to do. Font size for the terminal window. How's that? All right, you got it. Now this tab we don't need. I want to close that. So that's preferences. Now when you create this workspace, click on this collaborate tab. I actually don't need the tab. You need to share it. I'm going to show this share button up here. And I'm going to show you what you need to do. You need to share with Mark Swope, like that. I'm going to invite him. And then you want to also invite me. I'm CSUSBDT. And invite me. Of course, I don't think I can invite myself. Error. So you'll have two of us, Mark and myself, as collaborators on your project. And when you do that, make sure this is the read setting. So that's read-only access. That won't work for us. We need read-write access. So make sure that RW button is clicked there. All right, that's good. And then when you submit your work, I'm going to just clean this URL up a little bit. When you submit your work, see this URL right there? This internet address? I'm going to copy that. You need to paste that into the email that you send to Mark and CC me. Okay? So we're going to get that link. We can click on the link and go directly to your workspace. It'll open up and we'll see it just like this. So now, this workspace instance that we called CSC 201 is it's a virtual machine instance, or something like a virtual machine instance. I think it's not exactly a pure virtual machine instance. It's something I don't know the details. It has something to do with sharing virtual machines with others, but there is separation between the users, so it gives the appearance that we're in possession of the whole machine, something like that. I don't know the details of it, but I'm going to call it a virtual machine, because for sure it's a virtual machine, running on a real machine somewhere. Now, so on this remote machine, we can interface with it using the web browser. So we're logged into this web application, and we have a file system, which is shown right here. This is a hierarchical view, or a tree view of the file system, and there's only one file in there right now, this README file. I double click on that, I can read the README file. There's some YouTube videos you might want to look at, it's up to you. And so that there's this thing called file system. It's where it's a thing that stores your files. It's normally on it used to be always on the, well, not always. A file system can live on a CD-ROM, a CD, a removable flash drive. You can put files on these devices, read them, write them. You're a spinning hard drive, or what do they call the new memory, which is like flash-based? What's it called?
Solid state.
Solid state. That's it. Yeah, that's what I have actually. I can't remember the word. Okay, so I'm an old professor. I can forget stuff, right? But you guys have to remember things. You're young. All right, so all of those devices have what are called file systems. So you can read files from them, move them around, create files, modify the files. They're just like storage containers with these files. And these file systems, you can think of them as containing two things. And this is a simple, I'm just giving you abstractions to work with here. Obviously, there's just a lot more complicated, right? But we're not looking at all the details. We're just trying to formulate the next set of abstractions that we can use to move forward and solve the problems that I'm going to give you in this course. And so you can think of these file systems as having two basic things: folders and files. But actually, if you look into details, folders and files are kind of the same thing. But at our level, we can just say, well, there's folders and there's files, and files can go in folders, but folders can't go inside files. So you can have folders within folders and so on, and files within folders. So this gives us the tree view of that file system here. But then we also have what's called a command line interface down here. And if I do ls for list, it shows me the README file. This is called the console interface, or the terminal interface, or command line interface. All those words are interchangeable. Console, terminal, command line interface. Terminals have command line interfaces. There's lots of words there you can start using. And so if we were to create another file, so I'm going to go up here and then create a file. And I'm going to say hi in the file, and I'll save it. It wants a name. I'll call it main.cpp. You can see in this tree view, graphical tree view, I now have two files. But down here, it just shows one file. Well, that's because this is an interactive command line interface. I have to issue the command again. And now it gives me a current snapshot of what's in that folder. I want to say this is a little confusing here. The word workspace is sort of the actual name in the file system, but this Cloudnine program or Cloudnine application displays this workspace folder with the name CSE 201. So be careful about that. It could be a little confusing. If I do pwd print working directory, it shows me the path to my current working directory. So this is the path. These are folder names. The folder names are separated by slashes. There's a leading slash with nothing to the left of it. That leading slash represents the root folder in the file system. In the root folder, I'm going to show you what's in the root folder. I do ls/. Those are all the subfolders under the root folder. Now, we can't see those folders from this interface. This is only showing us that workspace folder and below. So this is a bit more limited. This gives us some more power, and we can see more things using the command line interface. And if I do list/home, then I want to see the contents of the home folder, which is in the root. And there's only one folder in the home folder called Ubuntu. And that, by the way, if you're familiar with Linux, you'll know that that's my username. On Linux systems, normally there's a top-level folder under the root called home, and under there there's a folder for each account on the system. And here, as you can see, there's only one account. The name of the account is Ubuntu. That's the user. If I look at what's inside Ubuntu, I do ls/home/Ubuntu. I see I have two subfolders under this Ubuntu home directory. So /home/Ubuntu is actually called my home directory. And I'm user Ubuntu. And in my home directory, I have two folders, lib, lib, I say, and workspace. This Workspace folder is what's shown here in this tree view. Just to prove it to you, we'll issue that command, ls, with that full path, and it shows the README file and the main file with extensions there, right? MD is Markdown. It's a Markdown language. And CPP is the C++ language. Those file extensions give a hint about the data that's stored in those files, the type of data. So once again, we're running our browser locally. This is called my local machine I'm running on. The browser is running on the local machine, but the browser is running JavaScript. You see there's a lot of JavaScript here running inside the browser that we loaded from the web server, from this web server. The web server here. That's at this host. That web server sent us this HTML code, the CSS code, and especially the JavaScript code. And a lot of JavaScript code is running, and it's talking to the web server. And the web server is providing us this interface to a virtual machine instance that got created for us on a remote server. And we're running in that virtual machine instance. Now, we could also work locally, like in, I'll show you like here. In OS 10, there is a utilities folder, and inside the utilities folder, there's this terminal program. This is the same as the other one, PWD. See? Well, they don't have a home directory. It's not Linux, by the way. It's not Linux, but this is a Unix operating system. All the commands that we're learning now in that workspace I was showing you are called Unix commands. Those commands are exactly the same on OS 10, because OS 10 is a Unix operating system. But we're not going to work on the local machine because everybody has different operating systems. Most people are using either Windows or Mac. Some people are using Linux. But just to harmonize everything together, we'll be using Linux in Cloudnine. So we all see the same thing. We can talk about the same thing. Any questions? Okay. Mark, anything I need to say that I'm missing? You can jump right in and throw stuff in there. Keep going. All right, I'm going to keep rolling here, okay? Oh, question. Yeah. C9.io. Get an account right now and invite me. If you get an account right now and add me as a collaborator, I can show everybody in the class what I see, okay? So that would be very useful to us if you can do that. And make sure you bookmark this place here. And this activity A1, there's the link to it right there. See that right there? That links to Cloudnine. This is in the preparation section of the A1, the first assignment. Let's see if anybody has done it yet. So I'm going to watch this. Cloudnine, go to dashboard. And look at this, shared with me. I've got this link, shared with me. Dustin, right? Are you Dustin? Back there. Okay, good, got it. This is what I see, okay? Look at this. That's you up there, because that's like a generic, thing. And that's me, because I uploaded my photo, so you can see me. So actually, I can see, we can see your cursor. Look at that, see that? Isn't that neat? So it's a collaborative tool. It's pretty nice. So you can see, yeah, he invited Mark as well. See, so we're both read-write. I want to make sure that that read-write is on there. Yeah, that's good.
Quick question.
Yeah.
So we'll be running all our programs on the terminal on the bottom?
Yeah, on this terminal.
Okay.
Yeah. You can run your programs locally and develop them locally, but when you submit them, you should submit through this Cloudnine workspace. And you might want to experiment. Try doing development on your local machine, using Visual Studio, or on a Linux machine, locally on a Linux machine, maybe in the labs if you don't have access to a Linux machine yourself. Or if you're, OS 10, you could try using Xcode. Like I'm using Xcode locally here, right? Yeah, when I run that terminal window, that's a Xcode. I can do the same thing. See, C++, that's the command to run the compiler. But that's the compiler that comes with Xcode. Actually, maybe it's installed on outside Xcode. I'm not sure. I'm going to check that. Well, I don't have to check it, but I don't know. So the programs that we're going to run are called console applications. So we just interact with them through the terminal window. That's why we can work remotely like this with this type of development environment. But if we were developing programs that ran in an application window, like the browser, like see this browser runs inside an application window, and then there's an X button here, a minimize and a maximize. See that? These buttons. When the user clicks those buttons, it generates an event, and the program catches the event and takes action. Like it'll shut down the program. Like if the program doesn't catch this close event, it won't shut down. You're not going to end up shutting. It won't shut down. Clicking the X isn't going to shut down the window. That's just a nicety provided for the programmer. So the programmer says, okay, we're going to let the user shut down the application by shutting down the window with that X. But the programmer ignores that event, and the app won't stop running. But that's graphical programming. That's programming with a graphical window. And there's two ways to sort of write code. One is to run, well, more than that, but an executable will either run inside an application window, or it'll run outside of an application window. We're going to write and interact with the user through this command line. So we're only going to write programs that run without a window and can interface with the user through the command line interface. So that's Dustin. Okay, great. So I'm going to shut you down there. Anybody else? There we go. Look at that. They're filling up. That's good. So everybody's going to need to create an account, and share with Mark and myself. Let's write our first program. And you can just copy that if you like. Here it is. Here is a program. This is me, right? Yeah. What is this one? Oh, that's that. All right, so there's a hello program. It just says hello. You can see the word hello in there. So it's going to say hello in this command line interface. So that gray dot up there means it wasn't saved, so I'm going to save it. That's a typical mistake students make. They forget to save their files, and their changes don't get incorporated into the program. I'm going to run the compiler. Once again, look here. We've got two files, a README file and a main file. Well, you know what? I don't need the README file. I'm going to delete the README file. Now I could go up here and delete it here using their tool, right? There's a delete in there somewhere. Actually, there is no delete there, is there? Well, if I right-click on it, it shows, does it show delete in there? Oh, it does, there's delete, but I'm not going to delete it this way, right? That's the way you normally delete things. But in this course, you need to learn how to do things with the command line interface. So rather than taking the easy route and deleting through that tree view, do it the hard way and use the command line interface. So I'm going to use RM, that's short for remove, readme.md. Did you see how fast I typed that word? Is that amazing? How did I type it that fast? I want everyone to remember this. It'll save you a lot of time. I just put an R there because I know, look, if the file name starts with an R, it's got to be the README file, right? It can't be the main.cpp and there's nothing else in there. And so the command line interface is a program, and it's reading our input, and it's carrying out, taking actions based on what we ask it to do through what we type in there. And it responds to the tab key. So when I press the tab key, it interprets that as me wanting it to print out or display the rest of the file name for me. So that's called command completion. It's very convenient. So you're going to see me do things. It looks like I'm typing pretty fast up here, but I'm not. Actually, I'm just hitting the tab key. Okay. So that's the remove command. So you have the command, which starts. So this is called a prompt, by the way. See this business here is information, and then you got this $sign. All of that section there, CSUSBDT : ~workspace space $space. All of those characters constitute what's called the prompt. And now this prompt it's prompting us. It's prompting us for a command. So we entered a command following the prompt, and the command is RM. Now this command takes arguments, and this RM command can take one argument, which is the name of the file or folder that you want to delete or remove. RM is for remove. So this RM command takes one argument, readme.md. Oh, did you see that blink off up there? See, it deleted from the tree view. And we can verify that's gone using ls. You see, now the README file's gone. So that's how you use the command line interface. These questions about how to use the command line interface will appear on the exams. The first quiz and the final exam. A lot of questions on the command line interface, so you have to know this. And the reason it's on exams is because two things. Well, you'll need to know the command line interface for other courses that depend on this course. Many of the computing courses that many of you will take and many of you won't take require this knowledge of the command line interface. Also, in the working world, if you're an IT person, you got to know this. This is foundational knowledge. If you do anything in the area of system administration, which involves management of remote servers, you're going to need to know how to use the command line interface. Or if you become a programmer, a software developer, command line interface. Or if you're doing scientific work, and you've got programmers that produced a program that does something very specific, but you have to use it at the command line, then you're going to use the command line interface once again. So it's very important. Now let's compile this main.cpp. Oh, like the command completion doesn't work on this for some reason. It does in my OS 10 environment, but not in Cloudnine. So I have to type that file all the way out. This is a new command. It's not RM. We looked at RM. We looked at LS. We looked at PWD. Better check the time here. We're running out of time? No. So now this is a fourth command that we're looking at. It's C++. This runs the compiler, the C++ compiler. It takes an argument, which is the file that contains the source code that we want to compile. This is it right up here. That's the contents of main.cpp. What does that mean, compile? Well, it means translate. It takes this code here, source code, it's a specification of some behavior we want the computer to perform. It takes this specification of behavior in the C++ language, and it generates machine instructions that can be used to feed into the CPU to carry out that behavior. So the behavior we want, we just want it to say hello in the terminal window. Okay? It's going to say, we run the program, and it says hello. That's the behavior we want. Now the computer doesn't read this directly. It doesn't understand this in that sense. We can't just execute this program from source code. We have to translate the source code into an executable file. This executable file contains machine instructions, which are fed into the CPU, and it causes the CPU to, read and write registers, read and write RAM, interact with the attached devices, the monitor, the keyboard. That's what happens. That's what we produce. Also interacting with the operating system, that's important. I'm just going to put that in there as well. So let's create the executable. So when I run this program, it says nothing, which is good. If there's a bug, if there's a compilation error, if there's a syntax error, if the compiler doesn't understand what we wrote, then it'll complain. Now let me give you an example. Suppose I just put an M right there, okay? That doesn't make any sense to have an M there. What is the compiler going to say? Look, it's pointing right at the M. M was not declared in this scope. This is an error. The compiler, which is a program, doesn't know how to translate our source code into an executable. It can't do it. And it thinks it knows why. It thinks it has to do with this M, which is true. We did that on purpose. So we got to go into our source code and modify the source code to make it correct syntactically. It's like fixing a sentence in an essay. Maybe you forgot. Oh, I forgot to use what do they call it? A subject and a predicate. I forgot the predicate or something. You got to go in there and you fix the syntax. There's a grammatical error there that's not working with your English teacher. You got to fix it and then feed the essay back into your English teacher's computer, and then you won't get that complaint anymore. So that's similar to this. So we're going to run this again. Oh, what happened? Oh my gosh, look at that. I get the same error. What's going on? I said this is a common problem, right? And I'm guilty of it just like you will all be too. I didn't save the file. I didn't save the changes. See the gray dot up there? So I got to save it. Oh, maybe I did save it. Did I save it? No, I could not have saved it. But it doesn't give me a save option. There it is. I need to select the window. And there is a shortcut for saving that I want to warn you about. See that on the Mac, it's Command S. On the Windows, it's Control S. But Control S is dangerous, and I'll show you in a minute why. Oh, did you notice A.out got generated up here? Oh, let's look at it here. ls, there's A.out. There's an asterisk after it. I think that means it's executable, but I don't know. I've never seen that asterisk before. Do you know, Mark, what that is?
Yeah, it's executable.
just means executable. I never saw it used that way. But the color coding shows it's executable. It's green. LS, by the way, takes a can be modified. The behavior of LS can be modified with these options. So I'm going to use the -L option to produce the long list. See that? So LS with -L, which is like the long list, it's showing this A dot out. And you see that X right there? That means it's executable by the owner. This X means it's executable by everybody who's in the Ubuntu group. And this last X here means it's executable by everybody on the system. So these are called permissions. And in this class, we're not going to get into these other than what I just mentioned right now. So we don't have to know about permissions. But if you're a computer science major or one of the other computing majors, you're going to need to know this. So you're going to read up on this anyway. If you're a math major, don't want to learn this stuff, you don't need to. All right. So we've got that. Once again, let me clear the screen. Clear is convenient. We've got this executable A dot out. I'm going to run this, and I'm going to show you the wrong way to do it first. So I'm going to run this file. I'm going to submit it to the command line interface. So command line interface, execute this program. It says command not found. What do you mean not found? It's right in the folder I'm in. But see, it's not looking in my folder. Where is it looking? Oh, I use the echo command here. $path. This is what's called an environmental variable, path variable. This exists on Windows, Mac, Linux, probably Android and iOS too, and any number of other systems. There's going to be a variable called path. When the $sign dereferences the variable, it says, I want what the variable represents. I don't want just the name itself. It's called a dereferencing operation. Echo means just print it out to the display. Just print it for me. So the $sign dereferences the path variable. In other words, it says replace path by what it represents. And feed that to the echo program. And echo just dumps out whatever it gets. All right. So this is a string, a long string, that contains these paths that are separated by colon. See that colon right there? The first path is /home/ubuntu.nvm versions node v/bin colon. So this is the first path here. That's called a path name, by the way. So it points to this bin folder that's deep inside this file system, many levels down into the file system. And when we issue a command, the command line interface is going to look through this path. It's going to look at all the folders in the path and check each folder for A dot out. It's looking for A dot out. It's going to look there first. Then it's going to look in the next path, which is this long one right there, see? Then it's going to look in the third one and the fourth one until it finds A dot out. And at the first finding of A dot out, it's going to launch A dot, it's going to run it for us. But in this situation, A dot out does not exist in any of these folders. And you may notice in this path, our current directory is not in that path. So it doesn't look in our current directory. That means we have to give it the path to the current directory. You see, that's the full path name right there, /home/ubuntu/workspace/A dot out. There's the total path. Do you see it? Now it runs correctly. It prints hello for us. But you know that there's many ways. Usually there's more than one way to do things. And rather than typing out this long path, we can just use dot slash a dot out. Now the dot means a special symbol understood by the command line interpreter as meaning the current directory, the current working directory. By the way, the word directory has exactly the same meaning as the word folder. It's the same thing. So dot means the current folder, the current working directory. So I'm going to go dot slash. So I'm telling the command line interpreter, don't look in the path to find a dot out. Look in dot. Look in my current directory. Now it runs, see? Now I'm going to change my current working directory. I'm going to use the cd command. I'm going to go, here's another special symbol, dot dot. Means go up to the parent folder. See, the prompt changed there, didn't it? See the prompt? And look, pwd, print working directory, that changed as well. We're in a new folder. So if we reissue this command, what's going to happen? Nothing. A dot out, no such file or directory. A dot out is not in the home folder. A dot out is in that workspace folder. So we can specify a path from our current folder to a dot out using this path name. So workspace slash a dot out. You see that? I could go, let's go to the root. I'm going to go to the root folder. See that? Root folder. Print working directory. So now this command will not work anymore. We have to give it the complete path to a dot out from the root. Oh, there is another shortcut. Anybody know the shortcut I can use here? It's right in the notes. That one right there. That's called a tilde. Tilde at the command line interface represents the home directory. So you use it like this. So if I want to run a dot out, I can go tilde, that's my home directory, slash, workspace, because workspace is not my home directory. This CSE 201, unfortunately, is in our home directory. Well, I don't know about unfortunately, but this CSE 201 is that workspace folder that's in our home directory, and that's where we have a dot out. There it is. Now I'm going to go back to the home folder, so I can go cd tilde. See that? You see the prompt. The prompt is giving me a hint about where we are. It's just showing the name of the current folder. It's not the full path name to the current folder, just the name of the current folder. And we can reconfigure that, by the way. I usually configure a different prompt, but this is the default prompt it could give us. And if let's cd into workspace. See, now we're at a new location. So I suppose I wanted to go to the home folder. Okay, I can think of so many ways of getting there. I can do cd dot dot to go up to my parent, because my parent's my home. I can do cd tilde, because tilde represents my home folder. I can do cd tilde home Ubuntu, just the path to my home folder. And there's one more choice. cd with no argument, the default location is your home folder. So cd with no argument is the same as cd tilde and the other forms that I showed you. 9 o'clock, 15 minutes ago. So I'm showing you how to move around the file system at the command line interface. We looked at PWD. We looked at CD. We didn't look at copy yet. Let's take a look at copy. Copy a file or directory. Here's an example. So this main, let's make a copy of main. So I'm going to see ls there. I see that main is in there. If I do cp main.cpp, I'm going to call it bye, buy.cpp. I'm going to this file, there it is, buy.cpp. See that? This got created for us. We're gonna say buy in this one. And by the way, this /n, that's a new line character. It means go to the next line. I'll show you what happens when we take that out. I'm going to use the Command S to save that. There's the buy.cpp. We created it with copy. Now we can compile that. Forgot that doesn't complete. It overwrote the old a.out. So we've got a new a.out. When we run that, it says buy. The old program has been overwritten. If you don't want to, if you want to, you can name programs. You go -o for output, and I can say, you know, bye, say. See that? Now that bye is executable. I'm going to remove bye. I don't want that. A.out is just a default file name. It's generated unless you specify it yourself. Yeah.
That's what I was going to ask.
Yeah. A.out is the default. Now override the default. You got to use the -o. -o. What would you call that? The -o flag. The -o. What would you call that, Mark? Parameter, argument. What's the right word for that? Option. There we go. Yeah, I like that one.
It's a flag.
Huh?
It's an option.
It's an option. It's not a flag. It's an option. -o is an option. So now we got copy done. Oh, I want to say, before we move on there, I want to warn you if you're on Windows. In Windows, you use Control-S to save something, all right? But the problem is, that'll print hi there, right? Command not found. If this terminal window has the focus, when I press Control-S for save, I lost control. My terminal window is now frozen. Because there's this ancient, what's the word? Ancient command, Control-S, to freeze your output device from the keyboard. And it's from the time when I was younger than you, that was around. So they still implement it. It's a problem because you're going to hit Control-S. I needed to have, this file needed to have the focus. And Control-S wouldn't freeze my command line interface, but the command line interface was highlighted, so I froze it. So I need to do Control-Q. And see, everything popped out there. It's because I hit a bunch of enter keys. I hit the enter key many times. And those events queued up in the input buffer. And the input buffer didn't get processed until I did Control-Q. Control-S will freeze it. Control-Q releases it. I don't think it has much application anymore, although you could freeze the output of a running command line program, and start and stop it, using Control-S and Control-Q. And actually, in the old days, I remember doing that. Now I just remembering, I'm going way back here, to your age. And PCs were first invented, and everything was on the command line. It didn't have Windows. There was no such thing as a window. There was no mouse. There wasn't even mice. And it was all at the command line. And so Control-S could stop, a lot of output from scrolling through your terminal window. So you could do Control-S, Control-Q. I remember doing that now. It was very hard to control. All right, that's getting into history there. Oh, we're stuck with that behavior. Just like we're stuck with weird things like, like PWD, print working directory, and LS. These are names that were created a long time ago, and they're just traditional names now. We just keep using those. All right, let's look at the next one. There's move. Move a file. Move. You can think of moving as also renaming. So if we want to rename by.cpp to main2.cpp, we use the move command. So it's move source to destination. So we're going to move by.cpp to main2.cpp. Basically, it's a rename operation. There it is up there. You can see it. You can also move something elsewhere. Like I can move main.cpp to my parent folder. I'm not renaming it. I'm just moving it to the parent folder. Now, this second argument, ... specifies a folder, so it's not going to change my file into a folder. It's going to move the file into that folder. And now you saw it disappear. Main.cpp disappeared from here. We can't see it from here, but we can see it from the command line interface. If I do ls ... it says ls takes this argument, which is the folder I want to examine. I want to examine my parent folder. And I see my main.cpp got put up there. That's where I moved it. I want to move it back again. So I'm going to ... I go up to the parent and then /main. So that name, that's the path to main.cpp. It's called a path name. And then I got to give a destination. That's the source. I need to give the destination. I'll make the destination ... That means my current folder. See that? Now it came back in again. You see that right there? Move main.cpp to the parent. It's out there. Now I'm going to show you a little bit different here. I'm going to move it and rename it. So I'm going to put it in my current folder, but I also want to give it a new name. I'm going to call it by again. So I give the path name to where I want it to be, plus the new name for the file. So there's lots of forms that these commands take. You just have to get used to them. You have to learn them. RM, we got that already. MK, dir, and remove dir. Let's do those. Those are good. Suppose we want to make a folder. We're going to call it assignment 1. What is these? What am I doing? Look at the assignment 2, A2. See that? Conditions. The source code files for this assignment should be placed in a folder named conditions. This is the second assignment. You've got to create a folder named conditions, all right, and put ex1.cpp, ex2.cpp, and so on. You have to put those files in this conditions folder. We need to create the conditions folder. Now you could do it right up here, right? I could do new folder somewhere in there. Maybe I have to right click it or something. Right click, new folder. But don't do that because you're not practicing what you need to practice to pass the exam, okay? Use the command line. We're going to mkdir conditions. Make directory conditions. There, it puts it right there. It's empty. Let's put something in there. Let's put the by program in conditions, and we'll call it ex1.cpp. That's what it's going to look like when you submit your assignment. I'm going to copy main.cpp to conditions ex2.cpp. Now I've got 2 source code files in there. See that? So when you submit your work, it'll look something like this. You'll have your source code files in a folder. mkdir is a way to make a folder from the command line. What about deleting a folder? I'm going to use RMDIR. We're almost done. This is the end. Here, Dad, hang in there. How much time is there? 4 minutes. An hour is kind of long. All right, so remove directory conditions. You can put the slash in there or take it out, doesn't matter. Can't do it because the folder's not empty. So I'm going to use remove conditions star. Be careful with star. Deletes everything. There's no undo. There's no undo in this. It's not like, using File Explorer or whatever it is. So I just deleted everything that's inside conditions. See that? So now I can reissue this RMDIR command, and it deletes the empty folders. You can only delete an empty folder. There's ways of deleting folders that are non-empty. I'm just going to show it to you because you should practice this stuff first and you have to be careful because you don't want to delete like your home folder, for instance. You want to do something destructive. Any questions? Is there something important I need to mention? People need to come to a lab session. The lecture is optional. And so make sure that you come to every lab. And that's it then. If there's no questions, we're done. Okay. There is a question.
What room is the lab in again?
358. 3rd floor. Okay, that's it.